Hey, Riley. How are you?
Good. How are you?
Good. Trying to open the review. Did
Okay.
you want to go over the review too, or the first one?
The first one.
Okay.
Well, the one that we were going over.
Okay. Do you remember where we left off?
I think we were going to start with exponents.
Okay. All right. That's right. I remember now. And I'm trying to um, I'm also trying to post answers to both of the reviews. Does it make sense to y'all when um, I when the answers are on the last page?
Yeah.
Okay. All right. Good. Yikes. Because I'm just trying to make sure, because somebody had just, before I got on here, had just emailed me. Sorry about that.
It's okay.
I want to make sure everybody has the answers to these too. And I'm going to let her know that all right. Fun with exponents. Hey, will you give me a heads up if anybody else joins too?
Okay.
All right. I felt bad because I'm 30 minutes late, but
It's
my
okay.
my uh algebra 2 kind of ran over. So I'm hoping because Lily had emailed me and I feel bad. Um all right. Here we go. Well, I keep hitting the wrong button. All right. We have x, and then we've got a -3. So you're going to combine that -3 plus 3. Okay.
Okay.
So then you've got 3x, and then -3 plus 3 is 0. So to anything raised to the 0 power is 1. So that's essentially 3 times 1. So that's 3. Because when you're dealing with exponents and it's multiplication, you add the exponents. Okay?
Okay.
So on number 8, we've got -2 as the exponent on the n, and we've got a 0 on the other end. So -2 plus 0 is -2. So the end result here is 2 times -2. But what a negative exponent does is that drives it to the denominator. So you've got 2 over n squared. So that takes the negative off of the exponent. It just put it in the denominator. So here's your answer.
Okay.
Does that make sense?
Yes.
Okay, good. Oops. All right, now on number 9, you want to go ahead and distribute that 2. When there's a power to a power, you multiply. So when you're multiplying exponents, you add the exponents. When you're dividing exponents, you subtract them. And when it's a power to a power, you multiply. So we're going to distribute this 2 right here to everything inside the parentheses. So you've got x raised to the negative 4. So that's going to be negative 4 times 2. So that's negative 8. Make sense so far?
Yes.
Okay, and then y to the 4th, that's going to be 4 times 2. That's 8. Times x to the negative 2, y to the negative 4. Now we're back to just plain old vanilla multiplying. So we've got negative 8 plus a negative 2. So that's going to give us x equals negative, or x to the negative 10. And we've got y to the 8th and y to the negative 4. So those exponents, I would take the 8 and I would add the negative 4. So that's going to give me y to the 4th. And when I follow the rules of exponents, that's going to leave y to the 4th on top. And because this is a negative exponent, it takes it to the denominator, takes it to the basement. So I should have y to the 4th over x to the 10th. Does that make sense?
Yes.
Okay. And this is this the second one? This is the first one, right?
Which one?
This is the right, I am going over the right review, right?
Yes.
Okay, good. Because I know that I have 2 out there. So I'm like, well. Okay, so number 10. I want to, my first term is going to stay the same because I don't really have anything to distribute. Well, I've got that y to the 0, which technically is 1, but I'm just going to leave it there for the time being. Now, this 3 here, Riley, it applies to everything inside the parentheses, even that 2. So 2 cubed is 8, and y cubed, or there's an understood 1 exponent on that y, so y times 3, if you will. And then x to the 0, 0 times 3 is 0, right?
Yes.
So now we'll add those. We're going to multiply our regular coefficients first. So 2 times 8 is 16, because they just get multiplied just like normal. Nothing changes for your regular coefficients. And then we've got an x with an understood 1 on it, and we've got an x with a 0 on it. So 1 plus 0 is 1. That scared me. And then 0 plus 3. So that looks like that. Does that make sense?
Yes.
Okay. So that's C. Okay. Sorry about my dog.
That's okay.
All right. Number 11. So here I can see with the division or the fraction bar, that's a division. So I'm going to divide my 3 divided by 3. They basically cancel out. So that leaves me 1 on the top and 1 on the bottom. And then I've got m to the negative 1 with no m on the bottom. But I know that that -1 essentially will eventually take me to the bottom. But now I've got, on the n, I've got a -4, and I'm going to subtract that other 4 because division means subtraction. So I've got a -8. So that means I've got really nothing left on the top. So I've got 1. And all of this, because of the negative exponents, are going to stay at the bottom.
Okay.
Does that make sense?
Yes.
Okay, good. Any questions about that?
Nope.
So far? Okay, good. Okay. On this one, I've got a y. I've got really, that's the only thing I have in the numerator. So I'm going to do -1 minus a -2, which turns into -1 plus 2, which then equals 1. So that y is going to stay on the top because that's y to the first now. And it's positive, so it stays on the top. And that 4x will stay on the bottom because there's nothing else to divide it by. Does that make sense?
Yes.
Okay, good. Now the fun ones, where there's lots going on. Let's see. I'm trying to figure out where I have lots of room because there's not a lot of room to write here. Okay, on this one, what we're going to do is I'm going to work on the bottom first. Okay.
Okay.
And then I'll complete everything in the denominator. All right. And then
All right.
I'll work back to the numerator. So at the in the top you have x, y to the 0. I'm just going to leave it as is, okay? And then on the bottom, I've got y, x to the 3rd times, and now I'm going to distribute that 4 to everything inside the parentheses. So I've got x, and then 3 times 4 is x to the 12th, right?
Yes.
And then y, and I've got 4 times 4, that's going to be x to the 16. Okay? And now I'm going to combine everything across the bottom. So, this would have the 4 up there because I still haven't done anything with that yet. So the next step is to take y, that's an assumed 1 there. So 1 plus 16, that's y to the 16. And then I've got x to the 3rd and x to the 12th. That's going to be x to the 15. Okay? And now I still got that 4. Now I'm going to distribute that 4 to everything on the inside of the parentheses. So that's going to be x to the 4th. And then 4 times 0 is 0. So that's y to the 0. Okay? You want to keep writing all that stuff down. And now I've got 4 times 15. So that's going to be what, 60? And then y to the 64 because 16 times 4 is 64. So now I've taken care of that. And now I have to simplify within the fraction bar. So I've got 4 minus 60 So that's going to be negative 56. So that leaves that in the bottom. Did I do that right? Yeah. So there's nothing left there. And then 0 minus 64, which gives me a negative 64, which basically just leaves it at the bottom. So I have nothing left at the top. So I have to remember that that's a 1, because essentially you're canceling out. It wouldn't be 0. It leaves you with a 1 there. Okay?
Okay.
And I have it written a little differently, but it is D. I can't help but write it in alphabetical order. Old habits die hard. Okay, does that make sense?
Yes.
Definitely lots of places to maybe, lose your way. But as long as you're just going step by step by step, and I would take lots of steps when there's that many operations going on. Okay?
Yes.
Nothing wrong with taking your time. I don't remember, how many questions on the review?
60.
Okay. You have 90 minutes. So I feel like you should be good. Do you feel like that?
Yeah.
Okay. Just take your time on some of these. Some are going to take you 20 seconds and some are going to take you a minute. So, all right. On this, you want to distribute that 4 to everything inside the parentheses. But maybe what we might want to do is actually work the top of the fraction bar first. Okay? So we'll do that grouping first. So 2 times 2 is 4. And then we've got an x to the first times an x to the second. So we add those exponents. That's going to be x to the third. And then we've got a negative 2 and a positive 3. That's going to be y to the first. All over x to the negative 1 raised to the fourth. Okay? So we've got 4 raised to the 4th power. That's going to be 256. And then we've got 4 times 3. That's going to be 12. And then we've got 4 times 1. That's going to be 4. All over 4 times a negative 1 is going to be negative 4. So now we have 256. And then we've got 12 minus a minus 4. So that's going to be 16. And then y to the fourth. So my answer is here. Does that make sense?
Yes.
Okay, good. All right. Did anybody else join us?
There's me and then one other person.
Oh, there is?
Yes.
Okay. Let me see. Oh, Ethan. Yes, I can do 55 and 43. I think we did do those the other day. So let me make sure Riley doesn't have any other questions in between there, Ethan. And then I'll go do those real quickly, okay? Unless you'd like to see him again anyway, Riley.
I'm good with that.
Okay. All right. Is there anything in the middle that you wanted me to do first?
I don't think so.
Okay. How are you feeling about factoring?
Pretty good.
Yay! I'm so glad to hear that. Okay, number 43. I'm going to start there then. Okay. On solve the equation by factoring. Okay. Let's just talk about factoring, that part of it, for just a minute. The very first thing that you want to do is factor it. But let's talk about, compare this question, number 43, to 42. What is the difference if you just taken just the equation itself Obviously, the numbers are different. But what is different about the format of the question? There's a significant difference between the two. And what is that? Anybody tell me?
The equal 0?
Yes, good job. There's an equal 0 right there. So this is an equation and this is an expression. Okay? With an expression, you're only going to factor. With an equation, with that equals 0, the first part of the problem is factoring. Okay? But you're not done. So when you see the word solve each equation by factoring, factoring is the first part, but there's still a little bit more. It means go just another step. Okay, so let's take number 43 and let's solve by factoring. So what two things multiplied together give you a negative 30? So that automatically tells me one number is going to be positive and one number is going to be negative, because that's what it takes to make a negative multiplication fact. But when you add those same two numbers, you get a positive 1, because that's where that x would come from. So what are the factors of 30? That's going to be 15 and 2, with the larger being positive and the smaller being negative. Or 10 and 3, where this would be positive, that would be negative. But that would give me a positive 7. The first one would give me a positive 13, so that's not going to work. So 6 and 5, with the positive being 6 and the negative being 5, that would give me a positive 1. So my factors are x plus 6, x minus 5. Does that make sense?
Yes.
Okay. Ethan, does that make sense to you? Okay. Yeah, you were writing it. Good job. All right. Not done yet, though. Because it now says solve. So I've got each one of these little factors set equal to 0. Okay? So when it says solve, that means that I'm going to take each one of those little factors. I've done factoring, so I've done part A. And now I'm going to set each one of the factors equal to 0 and solve. Little tiny miniature pre-algebra problems that we miss so very much. And so this is my answer. So that's what it means by solve by factoring. Okay? So factoring is the first part, and then taking each factor and setting it equal to 0 is the second part. All right? Let's try that same principle and apply it to the rest of these. Okay? Let's factor number 44. What two things multiply together to give you 7 that when you add them give you 8? Can you think of two factors of 7? Is Ethan typing?
Yes.
Okay. 1 and 7. That's it. Exactly. I can't see both screens at the same time. So then that's going to, is this making sense to you, Riley?
Yes.
Okay, good. N plus 7, N plus 1 equals 0. So now you've got the two little tiny algebra problems. You're going to take each factor and set it individually equal to 0. and solve for n. And you might pick up on the fact that basically it's the opposite of each of the factors. And what you're doing when you're solving the equation by factoring is you're finding out where this parabola would cross the x-axis. So these are also the x-intercepts. They are also the roots and the zeros. So whenever you're seeing a quadratic equation, you're either going to solve it by factoring, you're going to solve it by completing the square, you're going to solve it by taking the square roots, or you're going to solve it by the quadratic formula. But typically what you're going to find is two answers, and you'll see that later when we have that whole plus and minus thing. Or in this case, there's two factors. But it's where the parabola, if you were to graph it, where it crosses the x-axis. All right, let's look at number 45. So what two factors, when multiplied together, give you a negative 32 that when you add them, give you a negative 4? So basically that says if I know that I'm multiplying something and it's going to be negative, I know one of the factors is going to be negative and one of the factors is going to be positive. So the factors of 32, negative 32, that give you a negative 4 when you add them. So that means my bigger factor is going to be the negative one. So I've got negative 16 and 2. When I combine them, they don't equal negative 4. They equal negative 14. I've got negative 8 and a positive 4. So when I combine those, that definitely gives me a negative 4. So my factors are n minus 8, n plus 4 equals 0. We're still not done. We've done this part. We've done the factoring, but now we got to do the solving. So this is step 1. This is step 2. You take each one of the little mini algebra problems and you solve. You've got n minus 8 equals 0, which becomes n equals 8. And you also have n plus 4 equals 0, or n equals negative 4.
Okay.
All right. How does everybody feel about those now?
Good.
Good. Ethan, are you better on these? Okay, good.
And Lily joined.
Okay. Hey, Lily.
Hey.
How are you?
Good. How are you?
Good.
Are you watching Math Lab live?
Yeah.
Okay.
Wait, is there a way not to watch it live?
Just go on YouTube.
Oh.
Okay.
Well,
Are you
then how
talking
would I know that
about the math lab, Ethan? Ethan.
Hmm?
Are you talking about the math lab, not watching it live?
Oh, wait, you can hear me? Oh.
Yeah. I can now. I couldn't before.
Oh. Yeah.
Okay, yes, there is a way for you to. Once it's done, you can go back and watch it. The only risk is I might not have covered the question that you wanted to ask.
Yeah, that's what I was telling my brother.
Okay. So are you good on the factoring ones?
Yes, ma'am.
Okay, because we went through, I think we started with the square roots the other day, right, Riley? Or did we do the solve by factoring?
We did quadratic formula.
Okay. All right. And then Ethan, you wanted number 53?
Yes, ma'am.
All right. Is there one in the middle between there that you wanted, Riley?
I don't think so.
Okay. All right. Lily, if you have questions, I'll get to yours next, okay?
Okay, thank you.
Uh-huh. All right, Ethan. You said number 53. Correct? Find the value of C that completes the square. And I want to go one step further on these.
Oh, wait, that might have been the wrong number. Hang on.
Okay, because I want to do one thing since it was 53. You might probably want 55 or 56, but while we're
That
on
was 55
53,
and 56. Sorry.
okay, not a problem. I want to point out one thing on completing the square. Remember, it's half it, square it, add it.
Mm-hmm.
But I want to show you guys something. What's half of 22?
11.
11.
Yeah.
You were right. Now, what's 11 squared?
121.
Uh-huh. Well, this is what I want to show you. The whole reason that you're doing that is now I have p squared plus 22p plus 121. So I have made a perfect square binomial by doing that. That's what half it, square it, add it does. Okay? Does that make sense to you guys? That's the whole point of completing the square, which is essentially important for the rest of these. How are you all in completing the square? Is that what you need me to go over, Ethan? Or the quadratic formula?
That's what I need to. I just wanted to see how that's done to make sure I'm doing it right.
Number 55, 56, and then the quadratic formula?
Yes, ma'am.
Okay. All right. I'm going to need somebody to, because there's not enough room for me to write on that one without it just being really ugly. So I'm going to need somebody to read me that problem.
N to the second.
Hold on. Let me get my paper erased. N to the second.
Plus 16n.
Okay.
Minus 70
Okay.
equals 3.
All right. So what you did before when you were trying to find the value of C that completed the square, you halved it, squared it, and added it. But right now, where you would have to put that number for adding it, there's that negative 70. It's in the way. So you need to get it out of the way by adding 70 to both sides of the equation. So you've got n squared plus 16n equals 73. Now I have created the space to complete the square where you can half it, square it, add it. So half of 16 is what?
8.
And 8 squared is what?
64.
So we've halved it, squared it, and added it. So I'm going to add 64 to both sides because whatever you do to one side of an equation, you have to do to the other. But over here, what I've done right here is created a perfect square binomial. What was half of 16?
8.
So now I have that on this side. And over here, I have 137. This is where you would confirm that 137 is not a perfect square by typing that in your calculator. And I know that it's not. I also know that it's virtually divisible by very little. It's not divisible by 2, 3, 4, 5, or 6. It's not divisible by 7 either. So what you're going to do from here is you're going to take the square root of both sides. One of the reasons that you're completing the square is so that you can more easily take the square root. Okay? And now you'll be left with, on the left side, n plus 8 equals, and this is where your very key element of plus or minus, the square root of 137 comes in, because two negatives make a positive. So now, in order to isolate n, getting it all by itself, you're going to subtract 8 from both sides. So you got n equals, and then negative 8 plus or minus the square root of 137, which if you're going to write both numbers out, one of them looks like negative 8 plus the square root of 137, and the other one looks like negative 8 minus the square root of 137. Were you doing them right, Ethan?
Yeah, I was doing it it took me a second to figure out because you don't want us to finish the square. Just the multiple choice helped though. I was just making sure.
Oh, okay. Yeah, the multiple choice the multiple guess always helps. But for these purposes, no, I don't want anybody to get decimals or anything like that. I do want you to simplify the radical if it can be simplified.
Okay.
Okay. All right, let's do the other one just to make sure you're doing them right. And then we'll do the quadratic formula ones. Any questions about that one, Lily or Riley?
No, ma'am.
Okay.
No.
All right. There's just not enough room on the PDF on the other one to actually write it out. So all right. Ethan or Riley or Lily, will you read me the next one? Where is it? This one right here.
Oh, I got
Okay.
a to the second
A to the second
plus 10a
plus 10a
minus 42
minus 42 equals
equals -9.
negative 9. All right. So to complete the square, I need to create that space because this 42, the negative 42 is in my way. So negative 9 plus 42 is, what is that? The struggle is real for Miss Sparks today. 33, right? All right. A squared plus 10a. That's pretty bad. Been doing math lab all day. All right. Equals 33. I've now created the space to complete my square. So what's half of 10?
5.
And what's 5 squared?
25.
So I'm going to add 25. I've halved it, squared it, added it. Whatever I do to one side of the equation, I have to do to the other. So now what I've done, this right here, I've created or completed the square. It's a perfect square binomial. Ethan told me that half of 10 is 5. So here's my perfect square binomial. A plus 5 squared equals 58. So now I'm going to take the square root of both sides. And I've got a plus 5 equals plus or minus the square root of 58. Once again, one of the first things you want to check is to find out if whatever that is a perfect square. And 58 is not a perfect square. And there's not really anything to take out of it. That's the other thing you want to do is factor it to see if you can simplify the radical and see if you can take anything out of it. But you can't because that's 2 times 29, and 29 is a prime number. So to get a all by itself, so you know that you've done everything you can to that radical, so you can move on to isolating the variable. So you've got a equals -5 plus or minus the square root of 58. So your two possible answers are -5 plus the square root of 58 or -5 minus the square root of 58. Okay?
Okay.
All right. Now, good old quadratic formula. I'm going to need somebody to read me the next problem once I get all this erased. And with these, the most important thing you do before you start on the quadratic formula is to make sure that you have the equation in standard form. Because if you start trying to plug in numbers before you have it in standard form, you could probably miss a sign or put a value in the wrong place. So you want to make sure it's in standard form first. So what's the problem?
57.
4a to the second.
Oh, yes, Riley. I think we're on 57, I believe. 4a to the second
Plus 11a.
Plus 11a.
Minus 69.
Minus 69?
Well, I'm skipping ahead.
Oh, you skipped ahead. Okay. I was like, wait a minute. So it's equals 69, basically. Okay. I got you. So what you did is you already put it in standard form.
Yeah.
All right. I'm just going to show that to make sure everybody knows that that's what you did. Okay. You have to have a 0 on the right-hand side and everything has to be on the left. All right. So let's identify A, B, and C.
4 is A.
B is 11.
Mm-hmm.
And
C
C
is
is 69. So now we're going to plug that into the quadratic formula. So we've got the opposite of B, which is going to be negative 11, plus or minus. And then we've got 11 squared minus, and then 4 times A, which is 4, times C, which is negative 69, all over 2 times 4. Okay, so X equals, and then negative 11 plus or minus, and then 11 squared is 121. And here's where you need to be really careful, guys. You want to watch your signs. So you've got a negative 4 because of the minus there, okay? Times 4 times a negative 69, which equals a positive 1,104 all over 8. And I'm just saying, this is not a time to really skip steps, in all honesty, because it can be kind of shady running through here. Then you're going to want to check to see if 1225 is a perfect square. And it is. And it's a perfect square of 35. Does everybody understand how to check it on your calculator?
That confuses me a little bit.
How to check it on your calculator?
Yes.
Okay. So let's say on your calculator, you had already plugged in 121 plus 1104. Okay. You've gotten all of that. So now somehow on your calculator, you've got 1225 or whatever. What you would do is hit second. Do you have your calculator with you?
Yes.
You would hit second and then see the X squared button. Just above the X squared button, there's a square root.
Uh-huh.
So you'll hit that. So second, X squared. And then it should have a little square root thingy flashing at you.
Yes.
And then you would type in 1225 and hit enter. And what did you get?
35.
Yes. If you did not get a whole integer, that would tell you it's not a perfect square. So if you got something in a decimal, then you know it's not a perfect square and you need to factor in order to simplify the radical. Okay? So if you got, say it wasn't 1225, it was 1235. It would probably be 35 point something, something, something. And that's not a perfect square.
Okay.
Okay?
Yeah.
All right. So then now the next part that you're on is you're going to take negative 11 plus 35, and you'll get 24 over 8, which reduces to 3. And then you're going to take negative 11 minus 35, which is going to give you minus 46 over 8. Which should give you 5 3/4, I think. Yeah. So your answer is here. And see, these quadratic equations, you're looking usually to get 2 answers. Okay? Do y'all want me to keep going through the rest of them?
I'm fine. That made sense to me.
It did? Okay, do you have any other questions, Ethan?
Let me look through the packet real quick.
Riley or Lily, do y'all want me to do the rest of the quadratic ones?
I think we did that the other day.
We did. And y'all both feel pretty good about them?
I think so. Could
Okay.
you do the exponents?
Yes. And Riley and I did go through those just a second ago. Riley, if you don't have any other questions, do you have some other questions on the packet?
I don't think so.
I posted the answers on Google Classroom so you can check them. You don't have to stay if you don't want to see me go through those again, but if you have a question on another one, I'll cover it.
I think I might say just like,
See it again?
yeah.
That's fine with me. Stay as long as you like. Ethan, do you, if you don't have any other questions, I'm getting ready to go through the exponents.
I don't have any questions. You can go ahead and do that. Thank you.
Where are they? There they are. Okay. Lily, on exponents, what you're going to do when it's multiplying, you're going to add exponents. Okay. So, and that's only for those variables that have the exponents on it. Other than that, like there's an understood 1 in front of that. So you'll just multiply that 1 times 3. Okay. So when it's a regular coefficient, you'll just multiply just like you normally would. All right. So you've got 3, but now you have x to the negative 3 and you have x to the 3rd. Okay. So you're going to add those exponents. So negative 3 plus 3 gives you what?
0.
Yep. And x or 0 as an exponent to any number in the whole wide world, it doesn't make any difference what it is always 1. So 3 times 1 is 3. So the answer to that one is 3. All right, number 8. Once again, there's an understood 1 as a coefficient. So 1 times 2 is 2. And then n raised to the negative 2 and n to the 0. Negative 2 plus 0 is negative 2. All right. So now with a negative exponent, the rule for negative exponents is it goes to the basement. So that goes to the denominator. N squared. And that loses that negative. Once you take it to the denominator or take it to the basement, the negative exponent comes off. So the answer for that one is C. All right. Any questions?
For this number 7, why wouldn't you put that one to the bottom?
Okay. Because when we added it out, this x to the negative 3. So basically you had x to the negative 3 times x to the third. So you're adding the exponents, negative 3 plus 3, right?
Okay.
Which gives you 0. So we ended with 3x to the 0, right?
Yes.
Does that make sense?
Yes, ma'am.
So that's 3 times 1, so that equals 3. So you don't do anything to take it to the denominator until the very, very end, because you want to see what the exponent is, and then that will tell you whether it's in the numerator or the denominator on the very last step. And on number 7, our very last step, the exponent was a 0. It wasn't negative. Does that make sense?
Yeah.
It does, or not really?
Yes.
I actually I found one that I'm not too sure on, number 47.
Okay. All right. Well, I'll definitely get to that one. I'm going to flip through the exponents. What is 47? What type of problem?
Solve each equation by taking square roots.
Okay. All right. That's actually a good one to ask about. All right. Let me run through these exponents. On this one, what you want to do first is distribute the 2 to everything inside the parentheses. So you'll have x, and then when it's a power to a power, you multiply. So negative 4 times 2 is what?
Negative 8.
And 4 times 2 is 8. And now we have negative 2 and y to the negative 4. So negative 8 plus a negative 2 is a negative 10, right? And then 8 plus a negative 4 is a positive 4. Yes?
Yes.
Okay. So now we're going to determine where it goes. And so where would the x to the negative 10 go?
On the bottom.
Yes, ma'am. And you take the negative off because you got it in its right place. And where does the y go?
On top.
Yep. So it stays there. So you see what I mean by you wait till you get your final answer after you've combined all of your exponents. And then this answer here determines the placement in the final end. So you do all of the adding, multiplying, subtracting, and everything first. And then you determine how it's going to come out in its final answer.
Okay.
Okay. And that's why that on number 7, we had an exponent of 0, and that's just 1. So that's in our final answer. So it didn't have to move. All right, number 10. And then, Lily, what I might do is go to number 47 for him, and then come back and do the rest of the exponents.
Okay.
Is that okay with you?
Yes, ma'am.
Okay. What I'm going to do on this one is distribute this first one, this first variable right here. This stays the same. So I'm just going to write it down because in our first step, we're going to stay there. And then I'm going to distribute that 3. That 3 gets distributed to everything inside the parentheses, including the 2. So what is 2 cubed?
4.
Cubed. One more up.
Oh.
8. And then y to the third. And then what's 0 times 3?
0.
That's right. So you've got this. Now 2 times 8 is 16. And then x, this is an understood 1. 1 plus 0 is 1. And then y to the 0 plus 3 is y to the third. So that's your answer. Oh, you know what? I'm looking at number 11, and I'm kind of thinking, while I have y'all on this exponent train of thought, I really kind of need to do that because I hate to switch because I'm thinking about, yeah. All right, number 11. When there's a fraction bar on exponents, you're subtracting. So powers, you multiply, or exponents, you multiply. Multiplying exponents, you add. And dividing exponents, you subtract. Okay? So we're going to be, except for the coefficients, which the 3 is just going to cancel with the 3, and that's going to leave you 1. But now we have -1 on the m. So, but nothing at the bottom. So we're just going to leave that one alone. And then we've got a -4 minus 4. That gives me a -8. So I've got n to the -8. So that m to the -1, where's that going to put my m?
The bottom.
That's right. N to the -8, where's that going to put my n?
On the bottom as well.
That's right. So it's going to be that. Because everything else is canceled out on top and left me with a 1. All right. Has that making sense, Lily?
A little bit.
Not really?
Some of it is.
Okay, some of it is. Okay. On this next one, you don't have anything as far as a coefficient on top. So that 4 kind of stays at the bottom and that x stays at the bottom. There's a y at the top and a y at the bottom. So we need to combine those. And we combine those because there's a fraction bar, which is division. We're going to subtract the exponents. So -1 minus a -2. So that's -1 plus 2. So that equals 1. So y to the first. So that'll stay on the top, right? Because it's positive.
Okay. Yeah.
And then, so I've dealt with the y's, and that leaves the 4x at the bottom. Okay?
Okay.
Better?
Yes. A little.
Okay. All right, number 13. On number 13, you want to deal with the the grouping at the bottom first. Okay? And so I'm just going to leave the top alone at x, y to the 0. But on the bottom, I want to distribute this 4. Now, what do I do? How do I get rid of the 4? How do I distribute that 4? What do I do? This 4 right here. What do I do?
Would you multiply it to the other exponents?
You would multiply it to the other exponents. Good job, because a power to a power, you multiply. So 3 times 4 is what?
12.
And 4 times 4 is what?
16.
Good job. Now my next step is to combine everything on the bottom of the fraction bar. So I've got a y to the first and a y to the 16th. They're being multiplied, so I add the exponents. 1 plus 16 is what?
17.
Yes. And I've got an x to the third and an x to the 12th. So what would that be?
Would you add those?
Yes.
Okay.
So, because when you multiply, when they're being multiplied, you add. When it's a power to a power, you multiply.
Okay, so that would be 15.
Yes. And now we'll combine the top and the bottom. Well, yeah, we'll combine the top and the bottom. So I've got, this is an understood 1. 1 minus 15 is what? Negative 14? Does that make sense?
Yes.
Okay. If it doesn't, just tell me.
Okay.
But it does?
Yeah.
Okay. Okay. What doesn't make sense about that?
Just like, I don't know, these problems confuse me. Like, the bigger they are, I get more confused. The smaller ones make more sense. But
Okay.
the
Well, just, oh, that's okay. You just want to take it little by little. You know, we've just done one step each way.
okay. Yeah.
That's what you want to, you don't want to get ahead of yourself. And right now, all we're doing is this is kind of a little problem because you're looking at that x to the first. Basically, right now, the only thing we're looking at is this. So you would be looking at 1 minus 15. So what's that?
Negative 14
So if the exponent is negative, where does it go?
on the bottom.
So I'm going to stick that right there. So I've taken care of that. And now I've got the next thing I'm going to look at is the, and even if you want to write this on your scratch paper, Lily, you can. So now I'm looking at 0 minus 17. What's that?
Just negative 17.
Uh-huh. So if the exponent is negative 17, where does it go?
The bottom.
And now I've gotten rid of that. And the only thing left here is this. But I still have my 4 on the outside. So I'm going to, now what do I do when it's a power?
Multiply.
Yes, ma'am. So obviously 1 to the 4th is 1 still. And so 14 times 4 is what?
Are you still on that one? Get ready. It's fine. 6. 56.
Oh, yes, 56. And then 17 times 4 is what?
68.
There you go. And I think their answer is slightly different than mine just because they don't put it in alphabetical order, but there it is. I have to put it in alphabetical order. It just
Yeah.
crazy. If I don't. Okay.
All right.
Sparks,
Yes.
I have to go.
Okay, Riley. If you want to see some of the rest of them, you can always, there will be a YouTube link.
Okay.
And I'll post it on the lesson plan or Google Classroom.
Okay.
Okay? All right. Have a good day. Thanks for coming.
Thank you.
Yeah, you're going to do great.
Hmm.
Okay. Ethan, are you still there? Is he-
Yes, ma'am.
Oh, okay. All right. All right. One last one on the exponents. And then, okay, so Lily, this is another one of those bigger ones, but don't just take it one step at a time. So take the top of the fraction bar. And so you've got 2 times 2. That'll be first. That's going to be 4. And then you've got x, and there's an understood 1 there. And when you're multiplying exponents, variables with exponents, you add the exponents. So you've got 1 plus 2. What's that?
3.
So you've got x to the third. And now you've got y to the negative 2 and y to the third. So now negative 2 plus 3 is what?
1.
Uh-huh. So you've got y to the first. And you don't really have to write the 1 there. And now I've got x to the negative 1.
Okay. This is starting to make more sense.
Oh, good. All right. So you just break it down into little tiny bite-sized pieces and don't jump ahead of yourself. And now you can combine. So now I don't have anything to combine my 4 with, so I'm just going to leave her alone.
Wouldn't the 1 be changed to a positive?
Not yet.
Okay.
We've got to combine it first. But that's a really good question. It's still in the works. I haven't moved it around yet.
Okay.
I have to combine it with my other exponents to find out what it is in the end. But so now I've got 3. That's a good question, though, because you would think because it's already in the denominator, you would do that. But in all honesty, if there wasn't any other x's there, it actually gets pushed to the numerator. But I don't want to make your head explode. But what we're going to do now is combine that 3 and that -1. So 3 minus a -1 turns into a 3 plus 1, which equals 4, right?
Yes.
Okay, so I've got x to the 4th because you don't want to move anything around or take any exponents off until the very, very end. That's your last step. So you want to do all the other combining part first. Okay?
All right.
All right, so now we've got a y. So we've taken care of that. We've taken care of these, and now we're on the y.
Okay, so you move the x to the top, the denominator?
Yes, because when I combined my exponents of 3 and -1, it became positive.
Okay.
All right, so it went to the top. That's why I said you don't want to do anything until the very, very end because once you start doing your combining, it could change.
All right.
Okay, so now my very, very last step is to distribute this 4. And it goes to everything inside the parentheses. Okay? So 4 to the 4th is what?
16.
No, you're actually doing 4 raised to the 4th.
Oh, okay.
So do that on your calculator.
That's what I thought you were saying, like 4 times 4. That's like, okay.
No, ma'am. 4 raised to the 4th power.
256.
Yes. So 256. And then 4 times 4, that's where you got that.
16.
That's going to be 16. And then 1 times 4 is that. So my answer is here. So you just kind of want to break it down into bite-sized pieces. Don't jump ahead. Do all your groupings and just keep writing things out. Take it one step at a time. Okay?
Okay.
Because all of these bigger ones are really a bunch of smaller ones all put together.
Okay.
And so if you break it down into bite-sized pieces, you got it, girl. All right, Ethan, 47.
Yeah.
Okay. Taking the square roots. So what you're going to want to do on this, you've got 16k squared equals 64. So the very first thing that you want to do is to get the squared variable by itself. Okay? So you're going to divide both sides by 16. Okay?
Okay.
That's going to get k squared equals. And at this point, you can approach this one a couple of different ways. You can either divide the 64 by 16 if you wanted to at this point, or you could take the square root of the top and the square root of the bottom. Either way would work perfectly fine in this situation. I'm just going to do it this way. And then I'm going to take the square root of both sides, and that's going to give me plus or minus 2.
Okay, I saw what I was doing wrong. I was trying to figure out how to get it to where I just didn't get the squared variable by itself. That's what I was doing wrong.
Yeah, I was going to say that seemed to be a very common mistake, to be honest with you, on all of the quizzes and tests. You have to get that squared variable all by itself before you can take the square root of both sides. So like on number 48, you've got 36p squared equals 100. So you're going to divide both sides by 36. And then that's going to give you p squared equals 100 over 36. In this case, if I were to divide 100 by 36, it's not going to be very pretty. So I would take the square root of the numerator, because I can look at those and see that they're perfect squares. Another good reason to have perfect squares memorized almost through 25. But p squared, so what's the square root of 100?
10.
And the square root of 36?
6.
Yes. So I've got plus or minus. That's another key thing to remember. A lot of things, a lot of people were missing, but the multiple guess is going to keep y'all from that. But this can be reduced. So you've got plus or minus 5 over 3, which is here. You have to get the squared variable by itself first. Does that make sense to you, Lily?
Yes.
Did we do these the other day?
I think so.
Okay.
Miss Sparks, do you know what finals room we're in? Like our class? Like who's our teacher?
I do not. What final room were you in the other day?
Oh, well, I think it's different from math. But
Yeah, it's different from math.
I do feel like it is. I don't remember.
Are we just in the same as last year?
Yeah, where were you last year?
I was in Mr. Edmondson's room last year.
I had Miss Beers' room.
Oh, okay. It probably will be the same.
Okay, thank you.
Yeah, no problem. I'll try and look it up. Hold on, Lily. Let me see if I can find the math assignment. I don't think they shared that with us, though. I don't think they did.
I'm sure they'll tell us tomorrow. Thank you. I gotta go.
Okay, it is posted. I just can't remember where it was. All right. No more questions, Ethan?
No, ma'am.
Okay,
Bye.
good. Have a good afternoon. Okay, Lily, is there some more that you want me to go over?
Could you just go over one from finding the value of c that completes the square, just to make sure I remember it?
Yes, I'm so glad that you asked about that, because I have something I want to show you. I had a light bulb moment about this that I'm hoping will help you on completing the square too.
Okay.
So I'm glad that you asked that question. Okay. So this is my little bop it mantra of half it, square it, add it. And so the term that we're talking about when we half it, square it, add it is the B term.
Yes.
This one right here. So what's half of -2?
You mean half
-4. I'm so sorry.
-2?
Yes. And so what's -2 squared?
4.
Okay, so the answer is 4.
Okay.
But what I want to explain is that p squared, what you've just done is you've done this. You've halved it, squared it, and added it. So it looks like this. So you have created a perfect square binomial.
Okay.
So remember when you told me, or I accidentally told you, that half of -4 is -2?
Yes.
That's how you know what the binomial is going to look like.
Okay.
Is by the half. So let's do that on 52. What's half of 12?
6.
And what's 6 squared?
36.
So that would be this.
I was just making sure I remembered it.
Okay, so now it looks like n plus 6 squared. So down here, when you're completing the square, that's what you're doing.
Okay.
That's how those connect. Does that make sense? Do you
Yes.
see the connection?
Yes.
Okay, good.
Can you do one from the factoring, solve each equation by factoring?
Ooh, absolutely. I just somehow took everything down bad. Are you still there with me?
Yes, ma'am.
Praise the Lord. Okay, so the factoring. We'll just start from the top. Is that good?
Yes.
Okay. So on this, on number 28, what you're doing is you're looking for two factors that multiply together that give you a negative 28, that when you combine them, give you a negative 3.
Okay.
Okay, so let's think about the factors of negative 28. The other thing we can think about is when, in order to get a negative number when you're multiplied, one of your factors is going to be negative and one is going to be positive.
Okay.
And the bigger one is going to be negative because we have a negative number. And when you combine negative and positive numbers, you find the difference and give the sign of the higher one. So we have factors of 14 and 2, and the bigger one there is going to be 14. But negative 14 plus 2 is negative 12. So that's not negative 3. All right, another factor for 28 is 7 and 4, with the 7 being the negative 1 because it's the larger. And negative 7 plus 4 equals negative 3.
Okay.
So that's going to be the factor.
I was talking about the solve each equation by factoring, like 43.
Oh, okay. I'm sorry. Okay. All right. Well, I'm glad we had that quick review
Yes, thank you.
because that's going to play into this. When you see these instructions, you're going to think factoring like you just did. That's step 1. But it should, when you see the word solve each equation, it should tip you off that says, Lily, you're not quite done yet, because there's a step 2. Okay. And if you'll notice that there's a difference between this equation and this equation, in that this one has an equal 0 to it. Okay. That's the difference. This is an expression and this is an equation. So you're going to factor it first. So you're going to apply the same principles that we've been doing with regard to factoring. So what two factors multiply together to give you a negative 30 that when you combine them give you a positive 1?
I don't know.
Some factors. What are some factors of 30?
5 and times 6.
Okay, so 5 and 6. One of those would have to be positive and one of those would have to be negative in order to get a negative 30.
Oh.
Right?
Okay.
So, and the bigger one in this instance is going to be positive. Okay?
Uh-huh.
And
Okay.
the littler one is going to be that. So you've got x minus 5 and x plus 6 equals 0. Can't forget that part. Equals 0. And now I've got my two factors. So I've done step 1. And now I'm going to move to step 2, which is the solving. And I'm going to take each one of my cute little factors and I'm going to make it a small algebra problem and set each factor equal to 0. So I'm going to set this one equal to 0, and then I'll set that one equal to 0. And then I'm going to solve. Remember our sweet little pre-algebra problems that we had that were like this that we missed so much? Okay. So you've got 5, and then we've got x plus 6 equals 0. So my answers are 5 and -6. So it's just like factoring, and that's why I put them so close together on the test, except after you get your factors, you're going to put each one equal to 0. And what you also might notice, Lily, is essentially your answer is the opposite of your factor. If your factor is x minus 5, then your answer is 5 because it's the opposite of -5, which is a +5. If your factor is +6, then your answer is -6. It's the opposite. Does that make sense?
Yes.
Okay. All right, let's do the rest of them just to make sure that it really does.
Wait, so because you would be moving it over to the other side, so that's why it would be a -6.
Yeah, because you solved it.
Okay.
Remember over here?
Yes.
Take each little factor and then make it an algebra problem. And that's why. Okay?
Okay.
All right, let's do number 44. What two factors multiply together to give me 7?
There isn't one.
There's only two factors of 7. Actually. What are they?
Well, there's nothing that multiplies for 7.
What two things can I multiply together then? If it's a prime number, you know it's prime because it's only it and it's and 1, right?
Uh-huh.
Okay, so it's going to be 7 and 1.
Okay.
And they add up to be 8.
Oh.
Okay?
Yes, that makes sense.
Okay, good. That's okay. It's okay. We're getting there. That's good. You're doing good. Okay, so now you have n plus 7, n plus 1 equals 0. Okay? Now you'll set that factor equal to 0. So you set n plus 7 equal to 0 and solve for n and tell me what you get. What do you get?
Wouldn't it just be a -7?
Yep. And now you set that one equal to 0. And what do you get?
-1?
Yep. So your answer is here.
Okay, this all makes sense now. Thank you.
Oh, good. Good. So you feel good about 45 and 46?
Yes.
Oh, good. All right. Is there any others?
Can we go over solving each equation by completing the square?
Absolutely.
Okay, thank you.
Not a problem. Especially after we just did what we did, like this find the value of C that completes the square. I am going to ask a favor of you. Will you read me the first one?
Yes, ma'am.
Okay, I'm ready.
N squared plus 16n
I'm sorry, say that again.
plus 16n
Okay, thank you.
minus 70 equals 3.
Okay, so in order to complete the square, I want to do that half it, square it, add it that we just did a few minutes ago. But this 70 is in my way. So I'm going to add 70 to both sides to get it out of my way. Because I have to have that space right next to my n squared plus 16n.
Okay.
All right? To half it, square it, add it. I got to have this space right here. So what I've done is created the space to complete my square. All right, so now I get to half it, square it, add it. What is half of 16?
8.
What is 8 squared?
64.
So I've created the space, and now I'm going to fill my space with my 64. And whatever I do to one side of the equation, I have to do to the other side of the equation. Okay, so I have to add 64 here. I have to do it on the other side as well. Now, just like I told you before, I created this perfect square trinomial by halving it, squaring it, and adding it. And what did you tell me that half of 16 was?
8.
So this is the perfect square binomial that I created. Because if I multiplied out n plus 8 times n plus 8, I would actually get n squared plus 16n plus 64.
Okay.
Okay?
Yeah.
And now I'm going to add that, just plain old vanilla adding numbers for 137. Okay?
All right.
And now the whole reason that I complete the square is so that I can take the square root. So that's my next step. Once I get that square, I'm going to square root it. And so n plus 8, the square root of n plus 8 squared is just n plus 8. And the square root of 137, you would do that check in your calculator like we did just a second ago with that second and then the square root button and 137, and you're going to find that it's not a perfect square. So you just put that plus or minus, that good old plus or minus that we love so much, that gives us our two answers.
Okay.
Plus or minus the square root of 137. Now you want to get the n all by itself. So you've got minus 8 plus or minus the square root of 137. So my two answers are this.
Okay. Thank you.
All right, not a problem. Do you need me to do it the other one?
I think I'm good.
Okay, I think you're good too.
That'll be good.
Did this all make better sense to you?
Yes.
I'm so glad. If you go through it later on today by yourself and you get stuck, you know you can email me. I'm an old lady, so I go to bed at 9 o'clock, but up until 9 o'clock, I'm yours.
Okay, thank you.
Okay, so if you go through this and you have any problem, email me. I'll Google Hangout with you. If you don't want to do a Google Hangout, I'll even write out the problem, take a picture of it, and I can actually text it to your mom if you want me to, or I can send it to you via email.
Okay, thank you so much.
No problem. All right, take care, sweetie.
You too. Bye.
Bye-bye.